Okay, on 9-1, you guys were wanting to have a little help on that. Let's see if we can do that. So give me one of them that you didn't know how to plot on 9-1. Yeah. Yeah, well tell me which ones y'all needed help on 9-1. You said you needed help. Which one? Tell me which one you needed help on. Okay, what is 5? Okay, is it positive or negative one, Megan? Okay. So the first one, it tells you which radius you're on, right? So we know that we're out here on ring 1, right there, that little tiny one. Yeah, on mine it's pretty tiny. Okay, and then 5 pi over 4, if you're dividing them into fourths, each one of them is going to be 45 degrees, so the fifth one's going to be right here, so your point's right there. So this is the number of degrees, and this is the number of radiuses. Okay? Okay, well give me an example of a negative one that was on the sheet, and we'll just do it real quick. Negative 2.5 and negative what? 3 pi over 4. Okay, again, we would figure out where this was as if it were first 2.5, just plain old 2.5, and then we'll go ahead and use the negative 3.3 pi over 4. Okay, so these are 45 degrees. So there's the first 45, and then down here to 90 would be the second one. And then we've gone one more, so we're at 5 pi over 4. And 2.5 is right. There's 1, here's 2, here's 2.5. So if it was 2.5, negative 3 pi over 4. If I got it past 2.5? Oh, wait a minute. There's 1. Okay, 1, 2. Yeah, you're right. Okay, but ignore that one. All right, we'll erase it. There we go. All right, so the negative does what to it, though? What does the negative do to it, though? It flips it, so it's going to translate it over to the other side. So that's going to take it over here and put it on this one. So there's our second line up there. So we go 1, there's 2, and there's 2.5. So that's where your point would be for that one. The negative in front of the 2.5 is going to flip it across there, okay? It just goes backwards. It starts when they have the negative on the degrees here. It starts here at 0 and goes this way instead of going over the top like it usually does. Okay, so like you have, well, let's give me one real quick off the worksheet. Okay, like that. So first we're going to find 2 pi over 4, right? So pi over 4 is right here, and 2 would be out at the second ring there, so right there. Okay, but the negative on the front of it translates it to the other side. So it's on the third one over here, so there's 1, there's 2. It'd be right there. And then flip it over, yes. Okay, so let's look at today's worksheet real quick. Do what? Did you find it? Okay, so y'all find 9-2B real quick. I have an answer. You find it as if it's positive first. You find it like on this one as if it was positive 2.1, 2.5, and then this, and then translate it over. Okay? All right, so let's look at 9-2B real quick. Come on, open up. There we go. Do what? Well, I've got folks that are out of the room today, and I've got somebody in ISS, so this is for their benefit. All right, so here we go. Here's 9-2B. And let's make this just a little bigger so we can see it. And we'll do a couple of these together. So here's your first one. Let's try it. All right, first of all, you have to decide what kind of graph you have. Okay, so use your note sheet. And if you've got two that are being added together, what kind of graph do you have? It's a second note sheet. It's 9-2. It's the one, it's got a staple in it. There you go. Now look at the back. That's the worksheet. You need the note sheet. You're right. It is a lemniscate. There you go. Now flip it over on the back. Tori, show them real quick, and then y'all flip it over on the back. That's the one you need right there. There you go. Santos got it. Okay, now here, let's see what all this equation tells us. It tells us a whole bunch of stuff just to begin with. Right here, the fact that this number is smaller than this one tells me that it has a what? Yep, you're right, it is a loop. It does have a loop. If the first number is smaller than the second number, we have a loop. Okay, the fact that it says cosine, that it's cosine tells me it's on the x-axis. The fact that it's plus in between here tells me it's on the positive x-axis. Because if it's sine, it's on the y. If it's cosine, it's on x. Okay, y'all got that? If it's sine, it's on the y. If it's cosine, it's on the x. Okay, now remember to find the max. We take these two numbers and we do what? Add. We add them to find the max. So if we add 3 plus 5, we're going to get 8 for our max. Okay, and for the min, what are we going to do? Subtract them. So 3 minus 5 gives us a -2. Okay, y-intercepts. Okay, remember the number in the front tells you where your y-intercepts are going to be. So it's going to be at 3. And where else? -3. Okay, so we're going to use our graph here, and let's go plot these points real quick. Now, if you count out here, how many rings do we have? I think we have 6, don't we? So we don't have a ring 8, so we're going to go ahead and kind of estimate where that's going to be. So there's where our max will be, at 8. Okay, now our min, though, was at -2. Now remember, that's over here on this side, but it's -2, so where's it at? It's over here, so that inner circle's going to end right there. Okay, now let's put our y-intercepts on. Let's go up 3 and down 3 on the y. And hopefully you guys can draw these rounder than I can. I'm not very good at drawing them in, so you go ahead and try. It's supposed to be sort of circle around, come through here, back through 0, make the little circle, and then keep going back and around. So here we go. Let's try it. Oh, mine's going to end up looking like a beetle. Mine always end up looking like a beetle. Yeah, mine looks like a, I don't know, a demented beetle. There you go. Anyway, yours should look prettier than that. Here's hoping. These two? It's the number in the front, tells you what your y-intercepts are. I went up 1, 2, third ring, 1, 2, 3. It's on the y-axis. Okay, let's try another one. I'm going to do a little hip-hopping around here. Yep. You guys tell me what this one is. We're not going to graph it. We might walk through it real quick and see if we can get your points, but we're not going to graph it. I'll let y'all do that. But what is this if the number's the same? You're right. It's a cardioid, which I usually misspell, but I didn't that time. It does look vaguely like a heart. Yes, it does. And it's not ever going to have a loop, right? Okay, so we can figure this out. Where's our max going to be? Now this one's a little tricky. It's going to be on the which axis? X-axis. And is it going to be on the positive or the negative? Look at the sign in the center. Okay, so we're on the negative x-axis. Okay, now if I add 4 plus negative 4, what do I get? 0. So this is going to sound kind of strange, but our max is at 0. Now what about our min, though? Because we subtract them when we get our min. So it's 4 minus a negative 4. So it's at 8. You'll understand why it's a minimum when you graph it. Okay, what about your intercepts? Your y-intercepts? Where are they at? 4 and negative 4. Okay, so now you'd be ready to graph it. And we can go ahead and graph it, I guess, if y'all want to. You want to go ahead and graph it? Okay, so 8's going to be, now think about it for a minute. We're on the negative x-axis, so we're over here on this side. We went out to the 8th one, so we'd be out here. And I don't have a problem with y'all graphing them on your calculator if you want to see what they look like. Okay, now it's going to go up 4 and down 4. There's 1, 2, 3, there's 4. Chance, are you doing our soundtrack or what? Okay, and at 0. So now here's what it does. Remember, it makes the top of the heart here. It kind of takes a little bounce here and then rounds out through that point. Oh, it was supposed to look round. Mine doesn't. A number before what? Okay, number 7's a lemniscate. We'll get down there in there in just a minute. We're going to do number 6 next. I think we'll do number 6 next. Maybe not. Maybe we'll do... No, let's do number 5 next. I like number 5. Let's do it. Okay, you guys look on your deal and see what it is. If there's not anything being added or subtracted, what is that? Okay, the rose looks an awful lot like something else. Careful. What if it's just theta? Yeah, this one's a circle, isn't it? Okay, now be really careful because that 5 is what on this one? It's our diameter. Okay, the cosine tells us we're on which axis? X. Are we on the positive or the negative? Very good. We're on the positive. Okay, so we're going to run over here to 1, 2, 3, 4. There's 5. That's our diameter on our circle. And our circle just fits in right there. Okay, let's talk roses. All right, on the roses, if it's cosine, it's going to be a little easier than if it's sine. So we're going to start with a rose that's cosine. And then we'll go to a rose that's sine, okay? So on this one, let's talk about our rose. Now look at your note sheet. We know this is a rose. What is the 5 telling us? It tells us how many leaves or petals we have. Since it's odd, we have 5 petals. Since it's cosine, yep, but actually it goes all the way around on this one. I'll show you what the cosine means for us in just a minute. What's a 7 supposed to be? It's your radius. All right, now here's what we have to figure out. If we've got 5 petals and there's 360 degrees in a circle and we divide that up by 5 petals, how many degrees are going to be in between each petal? You're right, 72 degrees. So every 72 degrees we're going to have a petal, but we have to figure out where the petal's going to start. Okay, so to figure out where the petals start, here's what you do. When this is equal to the radius, we're at our max, right? So if we go ahead and we put in the radius equals 7 times 7 cosine 5 theta, and I divide both sides by 7, now I've got 1 equals cosine of 5 theta. I need to figure out what 5 theta is, so I'm going to take the inverse of cosine of 1, and that'll equal 5 theta. Now we're asking, what is the angle whose cosine is 1? So use your values chart real quick. Right. And what's really nice about cosine is it's always going to come out to 0 over here. So no matter what this is on this side, the angle is going to come out to 0. So the first leaf on a cosine rows is always going to start at 0. We like that. That's good. It doesn't matter how many petals it has, it's always going to start at 0. Okay, so we're going to go out here, and we know that we're on ring 7, so like right about here is where our first petal is going to be. And maybe you guys are better at drawing petals than I am. I hope so. Yeah, it is a big, long petal. Okay, then 72 degrees from here is our next petal. So we have to figure out where 72 degrees is going to be at. Okay, so on our 72 degrees there, since we got this measured out in radians, we know that pi over 3 right here is our 60 degrees. So it's going to be like 12 degrees past there. So it'll be right about here somewhere. Okay, so there's your next petal. Oh, I missed mine altogether. Y'all do better than that? We'll pretend I hit it. Okay, so if I'm at 72, I got 1 at 0, 1 at 72. My next one, you add another 72, will be at 144. Okay, so 144 is going to be about right here. And then add 72 to 144 at 216, which is going to be right about here somewhere. Okay, and then we add 72 one more time, and where are we going to be? Okay. So right about here. And we've got our rows. Okay, here's another rows. What's the difference on this one? It's sine. Sine's going to make a difference, but it's still a row. So let's see what we can fill in here. Okay, what? No, it looks more like a daisy, but they named it a rose. All right, so what's the radius on this one? 2. Now, be careful on this one. How many petals is it going to have? It's got 8 petals. Now, how do we know it had 8 petals? Because this was even, so if it's even, what do we have to do? Yeah, multiply it by 2. So times 2, got 8 petals, and there we go. All right, so we're taking our circle and we're dividing it into 8 equal pieces. So how often are we going to have another petal? Every 45 degrees. Okay, now, since this is sine, it doesn't start at 0, and we actually have to calculate on the sine ones where they start. Okay, so we go ahead and we set it equal to our radius. We say 2 equals 2 sine 4 theta. We divide both sides by 2, and so now we've got 1 equals sine 4 theta. Okay, we're going to do inverse sine of 1 equals 4 theta. Bless you. Okay, so look on your chart what is the angle whose sine is 1? 90. All right, so 4 theta equals 90. What's plain old theta equal? There's our starting point. Yep, you divided by 4. So we're going to start at 22.5 degrees. All right, well, this is 15 right here, and that's 30. And we're going to be on the second radius, which isn't out there very far, so it's going to be, I'm going to make that bigger so we can see it. Okay. So we're on the second ring, and we're right about there. Sort of in between those two, yeah. And there's your first petal. Now, every 45 degrees, which is every 3 of these, we're going to have another petal. So you can basically count off about 3 spots there and draw you another one. Because here's 15, 30, there's 45. Trying to get these in the right spot. Should be right about there. Yeah, they're pretty tiny on this one. Good. Who knew? Okay, so there should be all 8 of them. I think I missed one somewhere. Oh, wait a minute. Yeah, the last one. Well, thank you. No, I got it. There's your other one. Okay. So there's all of them. All right, so let's look at this last one. We're doing the Lemniscate. Lemniscate. Okay, so to find out, first of all, how many petals does it have on it? It's got 2. All right, now to find out the radius, this thing's being squared, so we need to take the square root. So the radius on this is the number in the front, square root of the number in the front. So what? So 5. It's cosine. So where did the cosine one start at? At 0. We like that. So we're going to go out here 0 to 5, which is what, right here? And it's going to come out over here We got 2 petals, so 360 divided by 2, we're going to have one every 180 degrees. So we got one over here too. And now it's supposed to look like the infinity symbol. Good luck drawing it. Hopefully it'll be prettier than mine. There you go. Yeah, it's like the propeller on the front of a plane. And we're done. Okay, this next one's super simple, and I'm going to let y'all do it real quick. What is it if they just tell us the radius is 6? You draw a circle, you're right. So this one's a circle. And so you go out to the 6th ring and you just trace it. Hopefully y'all can draw a better circle than I can. There you go. Okay, there's one I wanted to talk to you about on the back, and that would be number 13. What's number 13 when they just give you the angle? You're right, it's a line, plain old line. So you grab your handy dandy highlighter and find 5 pi over 6. Yes, it does. Nope, I left that one for you to do. So 5 pi over 6 is right here, and you just draw your line all the way through. And you're done. Okay, and then I'm going to let you guys try the rest of these on your own, I believe. I do. Nope, I think you can handle it. Okay? Got it? Okay, don't forget we're having a quiz over 9-1 probably first thing tomorrow, and we'll probably grade your 9-1 today. So, well, maybe not. Some of y'all haven't started it yet. We may grade it first thing tomorrow, so make sure you get your 9-1 done.